हेलो एवरीवन। आज हम लोग का टॉपिक है इंक्रीजिंग एंड डिक्रीजिंग फंक्शन। ओके, सो इन दिस चैप्टर में हम लोग मोनोटोनिसिटी ऑफ द फंक्शन के बारे में देखेंगे। तो यहाँ पे दो बात है, एक है कि मोनोटोनिक इंक्रीजिंग, एक है कि मोनोटोनिक डिक्रीजिंग। अगर x का वैल्यू बढ़ता है और फंक्शन का वैल्यू भी बढ़ता है तो ये मोनोटोनिक इंक्रीजिंग होगा। अगर x का वैल्यू बढ़ता है मगर फंक्शन का वैल्यू घटता है तो ये मोनोटोनिक डिक्रीजिंग फंक्शन होगा। ठीक है, तो इसके पहले कि हम लोग मोनोटोनिसिटी में जाए, पहले जो इनइक्वालिटी है उसका थोड़ा सा रिवीजन हम लोग कर लेते हैं, क्योंकि ये हम लोग को इस चैप्टर में चाहिए होगा। तो अगर हम लोग का a इंटू बी ग्रेटर देन ज़ीरो है, ओके, सो ये कैसे कैसे हो सकता है? अगर a ग्रेटर देन ज़ीरो है एंड b भी ग्रेटर देन ज़ीरो है, नहीं तो a भी लेस देन ज़ीरो है एंड b भी लेस देन ज़ीरो है। दोनों नेगेटिव है तो पॉजिटिव होगा, दोनों पॉजिटिव है तो पॉजिटिव होगा, राइट? इतना डिफिकल्ट है नहीं। अगर a भी लेस देन ज़ीरो है तो कैसे हो सकता है? a ग्रेटर देन ज़ीरो एंड b लेस देन ज़ीरो और a लेस देन ज़ीरो एंड b ग्रेटर देन ज़ीरो। कोई एक बड़ा कोई एक छोटा, राइट? कोई एक पॉजिटिव कोई एक नेगेटिव, का मल्टीप्लिकेशन नेगेटिव होता है। नाउ a b ग्रेटर देन ज़ीरो, अगर तुमको पता है कि a ग्रेटर देन ज़ीरो है, इसका मतलब क्या होता है कि b भी ग्रेटर देन ज़ीरो होगा। अगर a b लेस देन ज़ीरो है और तुमको पता है a लेस देन ज़ीरो है, इसका मतलब क्या है? b ग्रेटर देन ज़ीरो है, राइट? सो लेट अस से px and qx are polynomials. Then the inequalities then the inequations sorry inequations px by qx greater than 0, px by qx less than 0, and px by qx greater than equals to 0, px by qx less than equals to 0 are known as rational algebraic inequations. These are known as rational algebraic inequations. Okay, now we know the technique to solve this type of question. Let us say one question is something like this. We just have to know how to solve inequalities because we will need that. Let us say we have this inequality: 1 by x plus 1 minus 4 by 2 plus x whole square greater than 0. X is not equals to minus 1 and minus 2. Let's solve this first. So taking LCM, it will be 2 plus x whole square into x plus 1. This would be 2 plus x whole square minus 4 times x plus 1. Okay, and this is greater than 0. So this implies if you solve this, 4 plus 4x plus x square, and here 4x will get cancelled, right? So it will be 4 plus 4x plus x square minus 4x minus 4 by 2 plus x whole square into x plus 1. ऐसे 4 और 4 चला जाएगा, 4x चला जाएगा, so x square. So we got x square by 2 plus x whole square into x plus 1. This should be greater than 0, right? Now what we can do is multiply this thing in the numerator. Okay, or we can say this as x by 2 plus x whole square into 1 by x plus 1, that is greater than 0. So product of two multiplication is greater than 0. That means either both of them are greater than 0 and both of them are less than 0, but here is a square term, so both of them should be greater than 0, right? This is square term, and this will give always positive quantity. So this implies 1 by x plus 1 is greater than 0 and x is not equal to 0, right? So this implies if we multiply x plus 1 in the numerator and denominator, it will be x plus 1 by x plus 1 square, and if you cross multiply it will be greater than 0. So this implies x is greater than minus 1 and x is not equal to 0, right? Because here we have strictly greater than 0, so x should not be 0. So what is the solution? Solution should be, because it is given that x should not be minus 1 and x should not be minus 2. So our solution would be x belongs to minus 1 to 0 union 0 to infinity, right? Now let's see another question to clarify this. Now we have one solution. One question is x square minus 2x plus 5 by 3x square minus 2x minus 5, that is greater than half. We have to find the solution set. Okay, so how to solve? Take minus 1 in the left hand side. X square minus 2x plus 5 by 3x square minus 2x minus 5 minus half greater than 0. So this would be twice, if you take LCM, twice x square minus 2x plus 5 minus 3x square minus 2x minus 5 by twice 3x square minus 2x minus 5, that is greater than 0. So it is 2x square minus 3x square, that is minus x square, minus 4x, this is plus 4x, so it would be plus 2x, this is plus 2x, and this is minus 4x, so this would be plus 2x, right? This is minus 4x, right? So this will be minus 2x plus 15, 10 plus 5 divided by twice 3x square minus 2x minus 5. This should be greater than 0. So if we take minus common, this would be x square plus 2x minus 15 by twice 3x square minus 2x minus 5. That should be greater than 0. Now if we multiply both sides by minus 1, this greater than would be minus, this greater than would be less than, right? The inequality changes. So it would be x square plus 2x minus 15 by twice 3x square minus 2x, 3x square minus 2x minus 5 should be less than 0. So if you take middle term here, it will be x plus 5 into x minus 3, and it will be x plus 1 into 3x minus 5. You can cross multiply 2 to 0, right? Now if you multiply, make the square terms in the denominator, so it will be x plus 5, x minus 3, x plus 1 and 3x minus 5, and this would be x plus 1 square and 3x minus 5 square is less than 0. So this would be x plus 5, x minus 3, x plus 1, 3x minus 5 should be less than 0. Okay, so equating to 0, we will get x is minus 5, x is 3, x is minus 1 and x is 5 by 3, right? Now let us plot this in the number line. Okay, let the points draw in the number line. There is minus 5, is minus 1, this is 5 by 3, this is 3. So take the right hand side as positive, this is negative, positive, negative, positive, right? Here we need only negative terms, less than 0 terms. Okay, so this will be our solution set would be, our solution would be minus, right? Because here less than 0 is there. So x should belong to minus 5 to minus 1, and here it is strictly less than, so we will get open bracket union 5 by 3 to 3. So this should be our solution set. Now we understand how to solve inequality. Let us move forward to our next topic, which is strictly increasing function. Strictly increasing function. Okay, a function fx is said to be strictly increasing on open interval a comma b if x1 is less than x2. This implies f of x1 is less than f of x2 for all x1 x2 belongs to a comma b. So let's realize this with a curve graph. Let us say we have a graph something like this, and this is our y equals to f of x curve. Let us say this is our a point, this is our b point, this is our f of x1 point, this is our f of x1 height, this is our f of x2 height, this is our x2 point. Clearly it is in that x1 x2 is within a and b, right? Here we can see that if x1 is less than x2. Here x1 is less than x2, right? It is in the positive x-axis. So in the positive y-axis. So height of f of x1 is less than height of f of x2. So in this scenario, we can say the graph is strictly increasing function. Okay. Now let us see one question. So this should be our question number 3. Show that the function f of x equals to x square is strictly increasing function on क्लोज इंटरवल 0 ओपन इंटरवल इनफाइनाइट. इन्फिनिटी को कभी टच किया नहीं जा सकता, इसलिए ये हमेशा ओपन ब्रैकेट होता है, राइट? ओपन इंटरवल होता है. So you have to prove this as strictly increasing function. So let's see the solution. Okay, let x1 comma x2 belongs to this interval 0 to infinity such that x1 is less than x2. Okay, so we have assumed that x1 is less than x2. This implies if we multiply x1 in both the sides, this will imply x1 square is less than x1 x2. Again, x1 is less than x2. If we multiply by x2 in the both the sides, so it would be x1 x2 less than x2 square, right? Let us say this is our equation 1, this is equation 2. So from 1 and 2 we can say that x1 square is less than x1 x2 and x1 x2 is less than x2 square. That means x1 square is less than x2 square. So we can say, so from 1 and 2 we can say x1 square is less than x2 square. x1 square is your function, so f of x1 is less than f of x2. So we have assumed that x1 is less than x2 and we have proved that f of x1 is less than f of x2. So that means the function is strictly increasing, right? The function is strictly increasing. We have proved this. Now let's see our next topic, which is strictly decreasing function. Strictly decreasing function. A function fx is said to be strictly decreasing on open interval a comma b if x1 is less than x2. This implies f of x1 is greater than f of x2. That's all. Okay. For all x1 x2 belongs to a comma b. Let's see the graphical representation. Let us say our graph is something like this. Let us say this is our a point, this is our b point, this is our x1, this is our x2. This is our height f of x1, this is our height f of x2. So from the graph it can be seen that x1 is less than x2, but f of x1, the height of this is greater than height of this, right? So we can say this graph is strictly decreasing function. Okay, so let's see one question. It should be question number 4. Show that the function f of x equals to a to the power x, where a is between 0 to 1, is strictly decreasing on R. So let's see the solution. Let x1 and x2 belongs to real number such that x1 is less than x2. Okay, we have assumed this. So you can say x1 is less than x2. This will imply a to the power x1 is greater than a to the power x2, because we know a is between 0 to 1, right? If a is between 0 to 1, then and x1 is less than x2, then a to the power x1 should be greater than a to the power x2. If you have any problem regarding exponential function, please refer to our function chapter, where every graphical representation is shown. Okay, so you can say f of x1 is greater than f of x2. So we have assumed x1 is less than x2, but we got f of x1 greater than f of x2. That means our graph is strictly decreasing function. So the graph of a to the power x, where a is between 0 to 1, looks something like this. Here is the graph of a to the power x. Okay, we know this. Here a is from 0 to 1. If a is greater than 1, the graph would be something like this. So here we see that, let us say this is our f of x1 and this is our f of x2. So height of x1 is greater than height of x2, but the x coordinate is less than x1 is less than x2, right? So the graph is strictly decreasing. Okay, so let's move forward to our next topic, which is necessary and sufficient condition necessary and sufficient conditions for monotonicity. Necessary and sufficient conditions for monotonicity. Let's see. So here we have some theorem. This is the condition for theorem for necessary condition. Necessary condition. Let f of x be continuous on a comma b and differentiable on open interval a comma b. So number 1 point, if fx is strictly increasing on a comma b, then f dash x is greater than 0 for all x belongs to a comma b. Number 2 condition, if f of x is strictly decreasing on a comma b, then f dash x is less than 0 for all x belongs to a comma b. Okay, so strictly increasing हम लोग तभी बोल पाएंगे अगर f dash x greater than 0 होता है, that is फर्स्ट डेरिवेटिव greater than 0, और strictly decreasing तब बोल पाएंगे जब f dash x less than 0 होता है. Okay, that's all. तो अगर हम लोग इसको ग्राफिकली देखना चाहें, so let us say we have a graph something like this. Let us say we have a graph something like this. This is our y equals to f of x curve, and let's draw a slope here. This is our slope. Let's take this angle is theta, and this point as p, x comma y. Okay, and let's draw another curve. Let us say we have a curve something like this. This is our y equals to f of x curve, and we have drawn a slope, a tangent something like this. This is our tangent. These are the point px comma y. This is your tangent, and this tangent makes angle theta with the positive direction of x-axis. So clearly we can say that this curve is increasing function. This curve is increasing, right? This curve is increasing because a slope is positive. That's what it is told here, right? F dash x should be greater than 0. A slope is positive. So it's an increasing curve. And there is a decreasing curve. There is a decreasing curve, right? There is a decreasing curve. A slope, if you see, here slope is negative. It's greater than 90 degree. That's all it is told here. Okay, it's a very simple logic. So if slope is positive, that means the curve is increasing, and if slope is negative, that means the curve is decreasing. This as simple as that. Now this is our theorem 1, and we have theorem 2 regarding this. This is our sufficient condition. This is our sufficient condition. Let f be a differentiable real function defined on an open interval a comma b. Number 1 point, if f dash x is greater than 0 for all, a उल्टा है मतलब for all x belongs to a comma b, then f of x is increasing, f of x is increasing on a comma b. Number 2 point, if f dash x is less than 0 for all x belongs to a comma b, then f of x is decreasing on a comma b. Okay, this is a sufficient condition. So let's see some questions, because knowing theory and solving questions are two different things. Okay, so let's see different types of questions, so that this chapter will be very easy to you. So this should be our question number 5. So let us say question number 5. Find the स्टूडेंट्स को ये जो चैप्टर है इसका जो सम्स आता है ये बहुत डिफिकल्ट लगता है, तो मैं डिफरेंट टाइप्स ऑफ प्रॉब्लम यहाँ पे कर पाऊँगा, ताकि तुम लोग एग्जाम में यहाँ से जो क्वेश्चन आएगा वो हैंडल कर पाओगे. फाइंड द इंटरवल्स in which the function f of x equals to 2x cube minus 9x square plus 12x plus 15 is increasing. Number 2, decreasing. So you have the function given 2x cube minus 9x square plus 12x plus 15. So let's find out first derivative. It would be 6x square minus 18x plus 12. So let's take 6 common. This would be x square minus 3x plus 2. So we know for increasing f dash x should be greater than 0, right? So you can say 6 x square minus 3x plus 2 should be greater than 0. Okay, taking middle term, we will get x minus 1 x minus 2 should be greater than 0, right? Product of 2 is greater than 0, right? So you can say x is less than 1 and x is greater than 2. If we take, let's see it in the number line, so it will be more clear. We have 2 points, 1 and 2. So take the rightmost side as positive, this will be negative and this will be positive. There we have 2 positive sign at the right hand side of 2 and the left hand side of 1. So this means, and this is greater than 0, that means we have to take the positive signs. So this means x is less than 1 or x is greater than 2, right? So our solution here would be x belongs to minus infinity to 1 union 2 to infinity, and you can assume it as, you can check manually, right? If x is less than 1, less than, let us say 0. So 0 0, this is minus 1 into minus 2, that is greater than 1 0, right? And if we take x greater than 2, let us say 3. 3 minus 2 is 1, 3 minus 1 is 2, also greater than 0. It's better if you check it with the number line, it will be very easy, right? So let's check number 2, that is decreasing function, right? So we know for decreasing, f dash x should be less than 0. So this means 6 into x square minus 3x plus 2 should be less than 0. That means x minus 1 into x minus 2 should be less than 0. Now here the same number line, but here we have less than 0. That means we have to take the negative sign. So our x solution set would be between 1 and 2. If we check manually, 1.5, let us say 1.5. 1.5 minus 1 is 0.5 and 1.5 minus 2 is minus 0.5. It will be negative, right? So this will be our solution set. ओके, यहाँ पे कोई भी क्वेश्चन अगर अलजेब्रिक फंक्शन से ऐसे आता है, इसीलिए हमने तुमको पहले से ये एक दो क्वेश्चन हम प्रैक्टिस करवाए तुम लोगों को ऐसे, ताकि ये दिक्कत ना हो, क्योंकि ऐसे क्वेश्चन आने का प्रोबेबिलिटी बहुत है और इसका जो कॉन्सेप्ट है वो भी बहुत अच्छा है, ठीक है? सो और एक क्वेश्चन देख लेते हैं. लेट अस से दिस इज क्वेश्चन नंबर 6. फाइंड द इंटरवल find the intervals in which the function f of x equals to log of 1 plus x minus 2x by 2 plus x is increasing or decreasing. Okay, let's see the solution. The logic is same. For increasing, we have to make f dash x greater than 0, and for decreasing, we have to make f dash x less than 0. Okay, so before that, let's write down the function first. See, we know whatever is within the log, that should be greater than 0. So initially we can say x plus 1 should be greater than 0. That means x should be greater than minus 1. This is our initial condition. And base should be greater than 0 always. So here e is there, so it is greater than 0. So what is the domain of f? So we can say domain of f, that is the function, is minus 1 to infinity, right? Now let's derive this function. So if you take first derivative, it would be f dash x equals to log of 1 plus x, that is 1 by 1 plus x, and for 1 is 0, x is 1, minus you have to apply u by v rule here. So 2 plus x whole square, 2 plus x, and differentiation of 2x is 2, minus keeping 2x, differentiation of 2 plus x, that is 2 is 0, x is 1. So if you simplify 1 by 1 plus x, here it will be 4 plus 2x, and minus 2x will cancel out, that is 4 by 2 plus x whole square. Take the LCM, it will be 1 plus x into 2 plus x whole square. So it would be 2 plus x whole square minus 4 times 1 plus x. And after simplification, you will get x square by 2 plus x whole square into 1 plus x. It's the same question we have taken earlier, right? So you can make it as x by 2 plus x whole square into 1 by x plus 1, right? So for increasing f dash x should be greater than 0. This means x by 2 plus x whole square into 1 by x plus 1 should be greater than 0. Okay. Now see, this is a square function. It will be always greater than 0. So to become the product of this thing greater than 0, 1 by x plus 1 should be greater than 0. And x should not be 0, right? Because it is strictly greater than 0. So x cannot be 0, right? So we can say 1 by x plus 1 is greater than 0, but x cannot be 0. So this implies x plus 1 by x plus 1 whole square greater than 0 and x not equals to 0. This implies x plus 1 is greater than 0 and x not equals to 0. This implies x is greater than minus 1 and x not equals to 0. Right? So what is the domain? The solution set would be minus 1 to 0 union 0 to infinity. This is our solution set. तो आई थिंक इस टाइप का जो सम है ये तुम लोगों को समझ में आया होगा और यहाँ पे जो भी अलजेब्रिक फंक्शन में सम देता है वो इसी टाइप में होगा, इसे बाहर कुछ नहीं आता. तो लेट्स सी अनदर टाइप ऑफ प्रॉब्लम. क्वेश्चन नंबर 7. Find the intervals in which the function f given by f of x equals to sin x plus cos x, where x is between 0 to 2 due to 2 pi, is increasing or decreasing. You have to find the interval. So let's see the solution. It's a very interesting problem here. Here fx is given as sin x plus cos x. So let's find out f dash x first. So f dash x is cos x and differentiation of cos x is minus sin x. Okay. Multiply by root 2, divide by root 2. Okay. So in place of 1 by root 2, we can write sin pi by 4. So it would be cos x sin pi by 4 minus sin x cos pi by 4. This 1 by root 2 cos pi by 4, let us say. This is cos a sin a cos b minus cos a sin b. That is sin of a minus b. Now for increasing f dash x should be greater than 0. This implies root 2 times sin of pi by 4 minus x should be greater than 0. Okay. Now if we take minus common from this, it would be minus root 2 sin of x minus pi by 4 x minus pi by 4 should be greater than 0. Now if you multiply both sides by minus, this greater than would be less than. And take root 2 in the right hand side. So it would be sin of x minus pi by 4, that is less than 0. Okay, now we know the sign, the graph of sine is the graph of sine. This is 0, this is pi, this is 2 pi. And from pi to 2 pi, the sine curve is negative, right? So we can say here x minus pi by 4 should be between pi and 2 pi. So take minus pi by 4 in both the sides. So it would be 5 pi by 4. That should be less than x, less than 9 pi by 4. Okay, so we can say this implies x is between, this implies x is between 5 pi by 4 to 2 pi or 2 pi to 9 pi by 4. Okay, so see 5 pi by 4, this means this is 5 into 180 by 4. This should be 225 degree, and within 180 and 360 is 225. 9 pi by 4 would be, so 9 into 45, so it would be 405 degree. So it is here 405 degree. That means 360 plus something, right? Here. So we can say that इसको हम लोग पहले 2 पाई से इसको तोड़ लिया है, राइट? 5 पाई बाई 4 to 2 पाई and 2 पाई to 9 पाई बाई 4. इसका अलग होगा और इसके लिए अलग होगा, राइट? तो इसको हम लोग और भी तोड़ सकते हैं. 5 पाई बाई 4 is less than x less than 2 पाई, और इसको हम लोग बोल सकते हैं सी 2 पाई to 9 पाई बाई 4. 2 पाई to 9 पाई बाई 4 जो भी वैल्यू होगा, 0 to पाई बाई 4 जो भी वैल्यू होगा सेम होगा, राइट? So we can say it is equivalent to 0 to pi by 4. So our solution set would be x belongs to 0 to pi by 4 union 5 pi by 4 to 2 pi, right? So our function is increasing in this domain. Now for decreasing, f dash x should be less than 0. That means root 2 sine pi by 4 minus x should be less than 0. And if we take minus common, so minus sine x minus pi by 4 should be less than 0. That means sine of x minus pi by 4 should be greater than 0. Okay, this should be greater than 0. Now we know that sine is positive in 0 to pi. So x minus pi by 4 should be between 0 to pi. Take minus pi by 4 in both the sides. You will get x should be between pi by 4 to 5 pi by 4. Add pi by 4 in both of the sides. So from here we can say axis belongs to pi by 4 to 5 pi by 4, because 5 pi by 4 is 225 degree, right? And pi by 4 is 45 degree. So it is between 45 and it should be greater than 0, right? 225, 5 pi by 4. In the interval pi by 4 to 5 pi by 4, the curve is decreasing, right? The curve is decreasing. You can see that the curve is decreasing. So in this interval, the curve is decreasing. So यहाँ से जो क्वेश्चन आता है साइन कॉस देके, यहाँ पे साइन और कॉस का जो ग्राफिकल रिप्रेजेंटेशन है, वो ग्राफिकल रिप्रेजेंटेशन अच्छे से तुम लोग को ध्यान में रखना होगा, तभी यहाँ से जो सम आता है वो तुम लोग कर पाओगे। तो और एक क्वेश्चन देख लेते हैं। दिस शुड बी क्वेश्चन नंबर 8. Question is, separate the interval 0 to pi by 2 into sub-intervals in which f(x) sin to the power 4x plus cos to the power 4x is increasing or decreasing. Okay, we have to see this. So let us say we have f(x) is sin to the power 4x plus cos to the power 4x. So taking f dash x, it would be 4 sin cube x, and for sin x it would be cos x, and for cos cube x, for cos x it would be minus sin x. Or f dash x would be taking minus 4 sin x cos x common, it would be cos square x minus sin square x. So this is cos 2x formula, right? And we can take minus 2 and twice sin x cos x. We can break this thing as something like this: 2 sin x cos x into cos 2x. So this would be minus 2 sin 2x cos 2x, and this would be 2 sin x cos x is sin 2x, so this would be minus sin 4x, right? So interval is given 0 to pi by 2. So we have 0 less than x less than pi by 2. That implies multiplying by 4 in both the sides. It will be 0 less than 4x less than 4 into 2, that is 2 pi. Okay, because we have 4x here, so we make the equation in 4x. Now let's say case 1. When 0 less than 4x less than pi, that is because we know the sine curve is 0, pi and 2 pi. So we make the curve first in the domain 0 to pi. So 4 से अगर डिवाइड किया जाए तो ये हो जाएगा 0 लेस देन x लेस देन pi by 4. So 0 to pi by 4, from 0 to pi by 4, the graph is increasing and it is positive, right? So we can say sine of 4x is greater than 0 between 0 to pi by 4. Let us say this is your pi by 4. तो माइनस साइन 4x would be less than 0, right? माइनस से मल्टीप्लाई करेंगे तो ग्रेटर देन लेस देन हो जाता है. तो माइनस साइन 4x is your f dash x. So f dash x should be less than 0. So you can say f dash x is less than 0 between the interval 0 to pi by 4. Okay, so f dash is less than 0 मतलब decreasing function. So between 0 to pi by 4, f dash x is decreasing. Now let's take case 2. For x is between pi to 4 to pi. So 4 से divide कर दो. So this should be pi by 4 to pi by 2. Now this is pi by 2 and this domain pi by 4 to pi by 2. So you know, right, from pi to 2 pi, the sine curve is negative. So you can say sine of 4x is less than 0 in this domain. So minus sine 4x should be greater than 0. That implies f dash x is greater than 0. Okay, so f dash x is greater than 0 between this domain or this domain. That means in this it is increasing function. It is increasing function in the domain pi by 4 to pi by 2. So we have successfully break down the interval 0 to pi by 2. Okay, now let's see another question. This should be question number 9. Prove that the function f x equals to tan x minus 4x is strictly decreasing on minus pi by 3 to pi by 3. Sorry, so here fx is given as tan x minus 4x. So taking f dash x, it would be sec square x minus 4. Differentiate both the sides. So if we break down sec square x, it would be 1 by cos square x. So it would be 1 minus 4 cos square x by cos square x. Now f dash x is equals to, if you take 4 by cos square x common, so it would be 1 by 4 minus cos square x. Okay, so we can take it as 1 by 2 square minus cos square x. So it would be 4 by cos square x into half plus cos x into half minus cos x. Now the domain is given as minus pi by 3 to pi by 3, right? So this implies x is between open interval, so it is only less than sign. So minus pi by 3 to pi by 3. Take cos on all the sides. Minus cos of pi by 3 is cos of pi by 3, that is half cos x. Cos x is between half to 1, because if you take, what is the curve? The graph of cos x is looks something like this, right? This is the graph of cos x, and at cos 0 the value is maximum, and it is given that, and at cos 90, so this is your pi by 2 point, the value is 0, and at cos pi by 3 the value is half, 50%. So let us say this is your pi by 3, this should be your minus pi by 3. So this is your minus pi by 3. तो माइनस पाई बाई 3 से बड़ा होना चाहिए और पाई बाई 3 से छोटा होना चाहिए. सो हम लोग इसको हाफ हाफ से 1 तक बोल सकते हैं. ये हाफ से हाफ ये कोई मतलब नहीं होगा, तो हाफ से 1 तक हम लोग बोल सकते हैं. ओके, दिस या तो दिस हाफ से 1. So that means half is less than cos x, and we can say half plus half less than half plus cos x less than half plus 1, taking plus up in all the sides, because here we have half plus cos x and half minus cos x, right? So from this we can say half, take cos x in the left hand side, so half minus cos x is less than 0, and this is half plus half is 1, is less than half plus cos x less than 3 by 2, right? So we can say half minus cos x is less than 0, and half plus cos x, here the value is between 1 to 3 by 2, that means it is greater than 0. So you can say half minus cos x and half plus cos x, this value will always be less than 0, because product of less than 0 and greater than 0 is less than 0, and we have a square term here, so it will be positive always. So you can say 4 by cos square x, half minus cos x and half plus cos x is less than 0. So this means f dash x is less than 0, that means it is strictly decreasing, between minus pi by 3 and pi by 3. Okay, so this is a very interesting problem. Now let's see our last question, question number 10. Show that f of x equals to 2x plus 14 by 6 plus log of root under 1 plus x square minus x is increasing. on R, right? So let's see the answer. Here, first take differentiation on both the sides. So it would be f dash x equals to 2 plus cot inverse x, differentiation of cot inverse x is minus 1 by 1 plus x square, right? You know this. So this would be minus 1 by 1 plus x square minus 1 by 1 plus x square plus log of x, differentiation is 1 by x, so 1 by square root of 1 plus x square minus x, and differentiation of root under 1 plus x square to the power half, that is n into x to the power n minus 1. Okay, and differentiation of 2x is x square is 2x, so 2 will 2 cancel out, so it would be half minus 1, that is minus half, that is 1 by square root 1 plus x square, and differentiation of x is 1, so minus 1. So f dash x equals to twice minus 1 by 1 plus x square plus 1 by square root 1 plus x square minus x into x minus root under 1 plus x square. This should be here, x will be there, right? So x minus root under 1 plus x square by root under 1 plus x square. So यहाँ पे अगर ये कैंसिल हो गया तो ये minus 1 by root under 1 plus x square. Now see, we know that x square is greater than equals to 0. This implies 1 plus x square is greater than equals to 1, right? Adding 1 in both the sides. So this implies 1 by 1 plus x square is less than equals to 1. Okay, if we take inverse reciprocal, then greater than should be less than. And in the similar manner, 1 by root under 1 plus x square is less than equals to 1. So here we have minus sign, here we have minus sign. So minus of 1 by 1 plus x square, and if you multiply minus in both the sides, we greater than minus 1. Okay, and if we multiply minus in the both the sides, it will be minus of root under 1 plus x square will be greater than minus 1. Okay, so see here we have 2, and this thing is greater than minus 1. So let us say it is minus 0.5, and this is minus 0.5, whatever value it may be. Okay, so it will be a positive quantity. So you can say f dash x is greater than 0 for all x belongs to real number. X should not be 0. Okay, so you can say f dash x is increasing function. So I think ये तुम लोगों को समझ में आ गया होगा कि यहाँ पे जो क्वेश्चन है हम लोग कैसे करते हैं. सो ये जो चैप्टर है इसके लिए 300 लाइक्स का एम्स रखते हैं. अगर ये पूरा हो गया तो जेई और जेई एडवांस का क्वेश्चन हम लोग अपलोड करेंगे और बहुत सारा नया कॉन्सेप्ट सीखेंगे. हैव ए गुड डे.